Good morning, geometry class. Obviously, you can tell I'm not here today, and fortunately for you, this being Belton High School where everybody has computers, the learning does not stop just because I'm not here. We're going to continue to move on. This time I'm going to give you a video lesson that I'm recording myself, and we're going to take the notes just basically how we would do normally in class, except now you can check it out on your computer. Remember, you need to pause, rewind. If I go too fast, you can always pause it, rewind the video, and try to get caught up. We're going to start with the vocabulary. We're going to start with the definition of a proof, and we're going to be doing proofs quite a bit here over the next few days. And the definition of proof, it is a convincing argument that shows why a statement is true. A convincing argument showing why a statement is true. A lot of you like to argue, so quite frankly, you should be loving proofs. Honestly, a lot of students don't. Proofs require a lot of thought. Students don't necessarily like to think a lot about proofs, and this is basically, it's a type of question where you'll be given the problem and you'll be given the solution, but you have to fill in the middle parts. It's kind of like showing your work. Before we get to proofs, though, we're going to talk about a couple of postulates that relate to last class period. Now, last class period, if you recall, what we did was we were showing triangles were congruent to each other. And what you had to do, and I'm going to pull out the notes for section 5.1, but what you had to do is you had to list, here's the 5.1 notes, you had to list 3 pairs of congruent angles and 3 pairs of congruent sides. If you could get all 6 of those pairs, 3 pairs of congruent angles and 3 pairs of congruent sides, if you could list all that together, then you would show that those triangles are congruent. And that was a lot of tedious work. And to be honest with you, it was a little bit of overkill. You actually don't have to do that much work to show that triangles are congruent. There are some shortcuts, but they do require more knowledge. And we're going to learn 2 of those such shortcuts today. The first one is called the side-side-side congruence postulate, and it simply says that if 3 sides of one triangle are congruent to 3 sides of a second triangle, so 3 sides of one triangle are congruent to 3 sides of a second triangle, then the 2 triangles are congruent. The 3 sides of one triangle are congruent to 3 sides of a second triangle, then the 2 triangles are congruent. So you can notice it doesn't make any mention about the angles. No mention about the angles. It just shows 3 sides here, single tick, double tick, triple tick. And over here, I'm going to blow it up a little bit just in case you can't see it. Single tick, double tick, triple tick. If that's all true, then the entire triangles are congruent to each other. The angles kind of lock into themselves already. I can show that to you with an example here. I've got some segments. So I've got some segments here. And I've got some orange segments over here. And what I can do, and notice I've got a small, medium, and large, and the small, medium, large are exactly the same size. What I can do is take this set of segments, and I'm going to construct a triangle. So there's my bottom, and there's that side, and then there's that side. Like so. Well, they keep sticking to my fingers there. Okay, so there's one triangle. Now I'm going to use the same measured segments, same size segments, and I'm going to make another triangle. So there's that side. Let go. And there you go. And you can see that they make the same type of triangle. They almost look like right triangles. If it is, that was entirely by accident. They don't always make right triangles. But they are the exact same triangle. The angles lock in to the exact same measures on both triangles. So this angle here is the same measure as this angle up here. These 2 angles appear to be the same measure. and this angle appears to be the same measure of that angle. So that can be done without even measuring the angles, as long as the three sides of one triangle are congruent to three sides of a second triangle. Those measurements make unique triangles. So if you could think back to what you did last week when we were doing the unique triangles exercise on the posters, which are hanging outside the room, that's what we were trying to get to, is showing that if you have three specific measurements, they have to make the same triangle no matter how you attach the segments together. Okay, that is called the SSS postulate, and that's often abbreviated because it stands for side, side, side. Three sides of one triangle, three sides of another triangle, and that's universally accepted in every textbook and every classroom in the country. They all use SSS. So if you have three sides of one triangle congruent to three sides of a second triangle, that means that triangle MNP has to be the same as triangle QRS. QRS. Voila! So what you're going to do today is you're going to just see if triangles are congruent to each other by a specific type of measurement. So let's look at example 1. Does the diagram give you enough information to use SSS? And then it says explain, and the explanations are important. You've got to tell me why. So from the diagram, we know that HJ, that's got a single tick mark, is congruent to JL. It's got a single tick mark. I think I'll call it LJ. And that HK, notice it's double ticked, is congruent to KL, which is also double ticked. Hopefully you can see the double ticks. If you can't, follow along on your own paper. By the, what property is it? You know that JK is congruent to itself. Remember, that is the reflexive property. By the reflexive property, you know that JK is congruent to JK because all three pairs of corresponding sides are congruent. You can use the SSS postulate, side, side, side postulate, to conclude that HJK is congruent to LJK. LJK. Order matters. Notice we went HJK, so that went across the single tick mark, and then down to JK, and then LJK went across the single tick mark, down to JK, just like the other one did. So the JK, the just kiddings, the JK actually matches up on both triangles in the exact same position. And there you go. You have done your first informal little proof there where you've given reasons for everything that you've said. Next page. So the side, 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 or SSS postulate is one of them that we're going to work with today. The other one we're going to work with is called the side angle side postulate, which is abbreviated SAS. And that simply says if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. So what does it mean to be included? The included angle is just simply the angle that's between the other two sides. So you see how the angle is, these two sides make up the angle. The angle looks like it's between the two sides. That's what it means. The included angle has to be between those two sides. So PQ and WX are single ticked. QR and XY, they're double ticked. And then angle Q is congruent to angle X. So if that's all true, then these triangles are congruent. So if we go PQR in the first triangle, you have to go WXY in the second triangle. WXY. Again, if I'm going too fast, pause and rewind, pause and rewind. Does the diagram give you enough information to use the SSS congruence postulate and explain your reasons? So, excuse me, I believe it says SAS congruence postulate, explain your reasoning. So on part A, can we use SAS? Well, we know AB is congruent to CB because they're single ticked. And we know DB is congruent to itself by the reflexive property. Remember that, it is reflexive, and that is important. The included angle between AB and DB is angle ADB right here. This is the included angle. Excuse me, I went the wrong way. Should be right here. Ignore that. ABD. I got dyslexic for a second. ABD. And then included angle for CB in DB is CBD. They're talking about those right angles there. CBD. Because the included angles are congruent, you can use the SAS postulate, side, angle, side, angle, side, to conclude that triangle ABD is congruent to triangle CBD. And that's part A. Part B, I'm going to try to keep this on screen. Can we use SAS on this one? We know that GF is congruent to GH because they're single ticked. And we know that GE is congruent to itself. GE is in both triangles, so we have to write G is congruent to itself. But the congruent angles, and if you can see on your paper or see up here, the congruent angles are HEG and FEG. Those are not between the two congruent sides. I'm going to go ahead and tick mark my reflexive side in the middle there. Notice this angle is not between these two sides, not between the two sides on the bottom either. This is not an SAS because the angle is not between the two sides. The A is not between the two S's. So you cannot use the SAS congruence. What we should have had in order to use SAS is we would have to use the angles located here at G. If we wanted to use SAS, the angles here located at G would be the congruent angles. So it should have been this one and this one. HGE. So angle HGE should have been shown congruent. HGE should have been shown congruent to FGE. Angle FGE. But they weren't, so we can't use them. All right, we have come to a checkpoint. So you need to pause the video and try to do these on your own. No, seriously, pause the video. You need to pause the video and really try to do these on your own. Okay? Can we use either SAS or SSS on the first triangle? We have two sides in the bottom triangle congruent to two sides of the top triangle. And we do have the angle that is included, the angle that makes up the two sides in both triangles. So yes, these triangles are congruent, and they're congruent by SAS. Question 2. We do have two sides and an angle on each triangle, but is the angle in between the two sides? No, the angle is not in between the two sides, so we can't use SAS on this one. We cannot show that these triangles are congruent, because what we do have, instead of an SAS, we have an angle, and then a side, and a side. Angle, side, side. And there is no angle, side, side. Remember that. There is no angle, side, side. And if you don't understand why I'm emphasizing there's not an angle, side, side, ask one of your friends. They'll explain it to you. And if they don't know what it is, I'll let you know on next class period. But just remember, angle, side, side doesn't work. And then the last one, can we use a triangle congruency proof on this one? We've got a side here, the side here. We have an angle here and an angle here. And then we have our reflexive side in the middle. So yes, this one does work because we do have two sides in each triangle with the angle in between. So this one these are congruent for SAS. Now that concludes the end of video 1. Look, there's going to be 2 videos to this. This is part 1. When you go to part 2, the second video, we will talk about proofs.